A Consumer's Dictionary of Food Additives by Ruth Winter. I don't know this lady, but I can tell you that she has no business writing such a book, which of course sounds like a potentially libelous statement, right? How do I dare make it? Well, several reasons. One, we're not in the US. Two, let's face it, the chance that she's in this room is pretty remote. But third, most importantly, I think I can back up my argument scientifically. If my phosphate-fearing friend looked up phosphate in this dictionary of food additives, fine, from phosphate rock, alkaline, used in shampoos, cuticle softeners, bubble bath, water softening, all of that makes sense, right, for a cleaning agent. But looking a bit further down, also in incendiary bombs and tracer bullets. Now she would not only worry about her son being cleaned from the inside out, she'd worry about him bursting into flames and disappearing, but not without a trace. Ruth Winter makes the most fundamental of all chemical errors, confusing the element phosphorus with phosphate. Phosphorus is a nasty element, for sure. And elemental phosphorus is used and has been used as a chemical of warfare. It is used in incendiary bombs. But when you unite phosphorus with oxygen to make phosphate, you get a completely different entity. This is as if I were suggesting that we should worry about water because it contains hydrogen, and hydrogen is explosive, right? It is utter nonsense. So that in itself is a giveaway that this woman has no idea of chemistry. So what right does she have to write a book advising people on what to eat and what not to eat? She has no right. But of course you don't require such a right. There's no requirement to be scientifically literate to write about science. And when you go into a bookstore these days and you walk down the health aisle or the science aisle, unfortunately you find all kinds of works that are not science-based at all. They cater to the scientifically illiterate public who want magical solutions to complex problems. And that's what these kind of books tend to deliver. Give you a couple more examples of the extent of scientific illiteracy out there. This is an ad that got dropped in my mailbox in a circular. It's an ad for underwear. It's not bad underwear. It's made of polypropylene, which allows moisture to pass through. It's the kind of thing you want to be wearing in winter when you're skiing, for example, because you don't want moisture freezing against your skin. So it does let the moisture pass through, but let's take a look at this ad in detail. H2O, also known as sweat, is attracted to thermal skins like ants to a picnic. Our constant comfort process separates the H2 from the O, making evaporation take place much faster. It's an astounding claim. First of all, let's deal with the graphic artist who believes that in water you have a covalent bond between the two hydrogens. Now one would think that somehow this epic would have gone through some editing. Someone would look at this before it was printed. But apparently not. But that's not the worst offense. What we really have here is some magical underwear. Because as you can see, as the water passes through the underwear, it undergoes electrolysis. It gets broken down into hydrogen and oxygen. Now, that is some underwear that can do this, to supply the energy for the breakdown of water into hydrogen and oxygen. If that underwear really were able to do that, we'd have a solution to our energy crisis, right? Because hydrogen could be used as a source of fuel. Of course, what we're talking about here is not electrolysis, we're talking about evaporation. Evaporation is nothing more than a change of state. But that apparently is a mystery that is beyond the people who have concocted this. Now, this kind of absurdity is all over the place. I mean, hydrogen is indeed an explosive gas. I mean, if you think back to the Hindenburg or the Challenger, that was due to hydrogen. But not produced by passing water through underwear. And yet that's the impression that you would get from looking at that silly ad. Well, this is the kind of stuff that we try to fight through our office. And let me give you just a little bit of a background, because it is a rather unique venture. It really is the first time that any major university in the world, and we of course are that, as you well know, we're ranked anywhere from number 12 to number 18 in the world, depending on which ranking you look at. Obviously, we look at the 12. But it's the first time that any major institution has said that, you know, our job is not over the moment that our students pass through the erotic gates onto Sherbrooke Street. Because today there's such hunger for scientific information that if it isn't fulfilled in a proper, unbiased fashion, that people will end up listening to whoever is standing on top of the tallest soapbox, screaming the loudest. So once you leave McGill, you still have all kinds of scientific questions. And of course, even if you've never been to university, you have all kinds of scientific questions. And it is really the job of the university to educate at large, not only our students, but to the public. We are a publicly funded institution. We do have a responsibility to make sure that the public is as scientifically literate as possible. That's what we try to do. The people who are standing on those soapboxes, screaming loud, generally are your quacks. And they are very, very seductive with their romanticized information. It sells. Unfortunately, they are usually selling nonsense. They're selling falsehoods. But they can be dressed in the garments of science. There's nothing really quite as dangerous as when a scientist or when a physician goes astray, because they have all the appropriate language to convince the public of nonsense. It happens. It happens, unfortunately, too much of the time. So our task really is to try to demystify science, to try to make sure people are up to date on what happens in the world of science. We hope to foster critical thinking, separate sense from nonsense, and if all of that works, we hope to keep people out of the clutches of charlatans. And we try to do this in many, many different ways. I always thought that our office needed a logo, and I had proposed this to the university because I think it is very descriptive of what it is that we do. It's not that we're against eating meat, although, you know, probably too much meat being eaten in North America. What we're against is this commodity, which is being piled higher and deeper, and there's more and more of it. Unfortunately, the university didn't go for this logo, but I think it does describe very well what it is that we try to do, because there's just so much of this out there. For example, people are buying apple cider vinegar because they're being told that it can slash your cholesterol, reduces your risk of heart disease. But there's a lot more serious nonsense than that. People are buying apricot kernels, for example, because they've heard that it can kill cancer cells. Well, no, it doesn't kill cancer cells. It kills cells indiscriminately, and in fact, it can do a lot of good. But desperate people will do desperate things, and they will buy into nonsense. The amount of nonsense is phenomenal. This machine sells for $18,000, and last year there were 3,000 of these machines sold in Canada. What do these machines do? Absolutely nothing. They are just interesting looking laptops with blinking lights and then silly programs. They do absolutely nothing, but they claim to diagnose and cure every disease known to mankind. Just listen to this nonsense. The EPFX seal scans the body for 9,000 frequencies, each associated with a different compound, much as antivirus software would do for a computer. Operates at biological speeds, whatever that means. Charting the resonance or response of the body to these frequencies, comparing them to a norm and ranking them in degree of reactivity, identifying both acute and chronic imbalances. Clients can then be provided info about the results, and energetic therapy can be given. So you diagnose the disease, and then you match the frequency of the disease to eliminate the disease. $18,000, but they sold 3,000 of these in Canada last year, mostly to desperate people. And it's not the people that need to be blamed, because desperate people will clutch at any straw. It is the people who fool them with such nonsense. That's where the crime lies. Here's another one. This is the BICOM bioresonance therapy machine. And what does this do? It filters out your bad frequencies and replaces them with good ones. It receives the body's electromagnetic vibrations by electrodes. Internal filter system separates the healthy, harmonious vibrations from the unhealthy. The healthy vibrations are given back, that is reintroduced into the body. The unhealthy ones are electronically inverted. The opposite vibrations are created in this way, weaken the unhealthy vibrations in the body and erase them. Those of us who are somewhat scientifically minded, you ask yourself the question, how could anybody buy into this? I mean, how could anybody believe this? But you can if you have no idea what frequencies are, if you have no idea what energy is. And most of the public, of course, doesn't have any idea of that. So this sounds very, very seductive. There's a lot of confusing information out there as far as the general public is concerned. There's no question. Just look at some of the stuff that we're exposed to. One day we may be told one thing, the next day it's no longer good, right? It's absolutely confusing. Specific examples. We live in a scary world because you can be told to go out there and eat as many fish as you can because the fish are full of omega-3 fats. We've heard all kinds of good things about that. They reduce the risk of cardiac arrhythmia, reduce the risk of arthritis. Pregnant women who consume omega-3 fats give birth to babies with higher IQs. We've heard all about that. And then, all of a sudden we hear, gee, those fish also harbor mercury and PCBs. They're highly toxic. So you want to make sure that you stay away from that. So we get this kind of dichotomous information. We started to eat fish because we're told it's all healthy. So what do? Go back to eating the way we were eating before? I mean, even the most prominent fish consumers are starting to worry about mercury and PCBs, right? So we go back to eating our hamburgers or hot dogs and corn. We switched away from those because we were told that these were unhealthy. Now back to that, well, that hamburger, that harbors dioxins. Those are notoriously toxic compounds. We can't have that. But maybe we can have the buns until we find out that when you bake those buns at a high temperature, you produce compounds called acrylamides, and those are carcinogenic. So you can't have that either. But maybe you can have the corn. You probably heard that corn contains lutein. Lutein is an antioxidant, and even people who don't know what antioxidants are have heard enough about them to think that more of these is better. By and large, that actually may be true. So the corn, but you find out that corn may be genetically modified. And then that causes real panic in the pantry. People don't want the genes in their food mucked about with, or they say, at least if you're going to do that, tell us, give us a warning, right? Put it on the label. Well, the only warning that can be legitimately put on the label, genetic modified foods like corn, would be this one, because that is the only thing that has been scientifically documented. Indeed, there are people out there who are demonstrating, usually without any knowledge what it is that they're demonstrating against or for. Panic is created purely from not having enough scientific information. People say, okay, I don't want any of your GMOs, give me your organic food, right? Well, the fact is that organic is no guarantee of safety. You may remember last year the episode we had about spinach, when spinach had to be recalled. That was because it was contaminated with E. coli, and that all came from an organic ranch. Now, I'm not going to suggest that it was because it was organic. It just happened to be the unlucky place where a wild pig pooped.